Okay, we can get started. We have been teaching Xarray tutorial, and I really want to thank Bing for agreeing to do that on a very short notice, like a week ago. So thanks for doing that, and hopefully that can get everybody on the same page in terms of we have some R users who may have not used tools to read data, and can help you get started with reading data sets in place.
Awesome. Yeah. All right. So I'm Finn, if I haven't met you guys yet. I use Xarray a lot, but not a developer expert. So yeah, if anyone wants to jump in with added tips or tricks, would love to hear that. And please just shout out questions as I go along. I would way rather have this be more conversational than just listening to myself talk for an hour. So I guess for people who aren't familiar, Xarray is a Python package that's really helpful for working with multidimensional data arrays. So these are normally things like climate model outputs or reanalysis products, remotely sensed data sets. I guess a lot of the data sets we were looking at this morning with Felipe were tabular, and so pandas could easily handle that. And towards the end, he hinted at some of the benefits of Xarray, and we'll dive into that. I guess, so this is just kind of for an overview, just a condensed version of an Xarray tutorial that they have in their documentation. Those guys have all sorts of resources up on their page. You should be able to click on, I can send out the link in the, oh yeah, so they have a bunch of stuff on their GitHub, and all sorts of more thorough notebooks that could be interesting to explore later on. But yeah, so I guess for those who aren't sure what a multi-dimensional array means, something that you can envision a little bit like this. So we have more than 2 dimensions. So this would be something like latitude, longitude, and then a time dimension as well. Xarray, what you're normally going to read in is called a data set. So this will be like one variable of, or multiple variables of interest with those dimensions. So latitude, longitude, time. If you're working with something like a model output that might have multiple elevation bands, then you could have 4 dimensions. And then within that entire data set, that could have, as they're showing here, temperature and precipitation. You have one variable of interest, and that's your data array. So that's mostly what we're working with. Yeah, so I guess let's just start working through things. So we're just importing package and then suppressing some outputs so that things are a little more readable. In this first notebook, we're just using a built-in tutorial data set that is available through Xarray. So we aren't actually reading in any data from an external source, but we'll get to that in the second half. So here's what an Xarray data set looks like. You can see it's a data set, not a data array, right up there. And then it's going to give you the coordinates. So data sets have coordinates and dimensions, which seem a little redundant, but I guess how I think about that is the dimensions are just like the X or Y axes labels, and then the coordinates are kind of like the tick marks. So your dimension is latitude, and then your coordinates are values of latitude, array values at set intervals. And so these coordinates are kind of what we're building our grid on, and define the location, time, if there is a 4th dimension of our data variable of interest. Yeah, and you can click on, so these little guys over here show you the actual array values, and then this will show you some more metadata information. And I guess the main selling point of Xarray is that it's really good at preserving metadata for large array data sets. So these things can get pretty big and messy, and it helps to just it helps you know what you're working with basically, so you don't get distracted by huge arrays of a bunch of numbers and have no idea what you're looking at. So this is our base data set, and then we can look at our variables. Here we just have one, and we pull it out like it's a dictionary object. Oh. Maybe. Should be able to pull it out with either.
As of the network drop.
Okay. Nice. There we are. Sweet. Yeah, so a few different notations, so we can think of data array as like a dictionary object within our full-on data set, and so we can call it using just standard Python dictionary syntax, or Xarray also makes it a little easier to just do .air. I think whatever works for you, you can use. I typically use this just because this kind of syntax is what we use for built-in operations, things like resampling, grouping, taking means. And so in my head, it just helps to have kind of distinctive syntaxes for different types of operations. Yeah, so now I guess by calling these objects, we're one level lower and actually have the values of our air temperature variable. When we were looking at our data set, we were a level above that. Can see some of the metadata through things like .name. And here we're just assigning our data array. DA is extracting this air temp variable from the data set. Yeah, if you don't want to print out the whole array and look at the dimensions like this, you can access them through these kind of commands, .dims, .chords, and then you can also extract your coordinates by calling lon, lat, time, anything like that. Or you can use the dictionary syntax as well. And then you can kind of see a big overview of the metadata through using that attributes command. This is nice. It shows you kind of everything that is associated with the metadata. They were excited in their tutorial about adding your own attributes, which I've never used, but I guess maybe if you were building your own arrays or had your own model you were running and wanted to add some additional information, that could be helpful. Good to know. And then this next section is nice because I think it shows a lot of the benefits of why Xarray is a lot easier to use and a lot more intuitive than NumPy. So this is looking at the arrays themselves, and this is how you would kind of view these objects if you just read them in as NumPy arrays. A little overwhelming. So there's our NumPy array. And then if we look at, this is how we would call it in NumPy. And of course, Felipe mentioned this earlier, Xarray is really good at populating axes labels and everything. And if we were just working with a raw NumPy array, it's a lot harder to see what's going on here. And particularly here, we're just accessing the data through their index within the array. And then in Xarray, we're actually specifying like what dimension we're calling from. And you can use .iso, which is the index selector, or just, let's go. something. I don't think you have to. Dot cell to access a specific time. A lot of people use like dot icell just off the bat to make a super preliminary plot. You just want the first time step. You can get a general idea of the data you're looking at, and then go from there to make more specific plots based on what you're actually interested in. Next part of this tutorial is just all of the operators that are built into Xarray. So it's really good at like taking means over certain dimensions, doing resampling, grouping certain dimensions together. So here, I guess we're compressing the entire time dimension. So we're averaging the air temp over the entire period. Yeah, we'll get into how to use that a little more next. Covered this briefly, but so the cell operator pulls out a certain time step. And then if you're interested in subsetting, you do cell and can use just a slice like you would in a NumPy array or a list. So yeah, I guess we can do a quick comparison here. If we have DS, then we'll call this DS subset. So here our data set starts in 2013 and goes to the end of 2014. Here we are pulling out what should be just from May 2013 to July. And looks like we now have that subset. Yeah, pretty intuitive. Any questions so far? Cool. And then another nice feature is this method equals nearest. So up here we were going in and actually looking at how I guess what time steps are available. Those are normally pretty standard and easy to get the slices right. For coordinates, if you're working with model output, I feel like things are always on different grids and that's a little hard to keep track of. And so instead of having to look at the array and figure out the steps you have available, you can just kind of take a guess at the general area you want, use this method, and it's going to grab whatever is closest to that. So looking for something roughly in this range and end up with a longitude value of 240. And then this is kind of the extension of that. So here we're inputting actual lists of values. So we want a few specific values roughly around these points for both latitude and longitude, and then are using that method argument to extract those. Yeah, we could see, let's add two. And now we have a few more as well.
What is the other methods? There is nearest method and there.
Say it again, sorry.
So you use like method nearest.
Yeah.
And what is the other methods? Is there?
Oh, I don't know if there are others. I always use this one, honestly.
It's just nearest right now. There, I believe there's talk at doing interpolation as selection, but they made that a separate method. So it's just so if you don't have nearest and you don't, and the value you pass there doesn't match up to a coordinate value, then it errors.
Yeah, so like, if you remove that, then, right, our values are,
See, back, finger blocks. And back feeling, and I think. Feeling. Forward, backward, maybe for sometimes see this. Here.
okay, yeah, I'm sure. This one covers most use cases for me, but it seems like there's a few other options if you wanna dive in.
I will say that the doctor and Xarray are fantastic.
So good, yeah,
And these things all work really well. One of the challenges can be that if you have a model grid that you're working with, that is slightly different in the way it's organized. A lot of this stuff needs fiddling to work properly.
Yeah.
I work with the ROMs model a lot, ROMs output, and it took me a while to get my head around how to think in ROM coordinates. And then use the docs to like, because the ROMs has, the dimensions are a little bit different. Than the way that this density is set. So,
yeah,
but the docs are, there's a lot of other examples out there, so if you just get a Google around, you can see the.
and there's a few packages which we'll mention at the end, which are built for Xarray and help with like regridding for different model grades, and or I've had to write just short helper functions before that'll switch the order of your latitude values because Xarray expects a certain order and a lot of them come in the opposite. Yeah, so I guess now we're back to sort of NumPy to Xarray comparison. In a NumPy array, you're just going to use those positional indexers, which easy to lose track of. Okay, we're taking the 0th value of what dimension. Whereas in Xarray, you have to specify where you're pulling things out from. And I think you should be able to, don't have to worry about. Yeah, so then you aren't as worried about the dimension order or anything, and can kind of just type things in real quick and look at what you want. Yeah, this is slicing again. But here, since we're using iCell instead of cell, we're just gonna take a slice of 10 values, so we don't have to specify like the start and end point. So again, I guess this could be helpful if you're just trying to look at the data briefly. Okay. All right, I guess sort of moving on to some of these built-in features. Any questions on that first section? Sweet. Okay, so I think this is a lot of where Xarray really excels. And what they're doing here is mostly built on NumPy and Pandas features, but just adapting it for those more complicated array data sets. So the main arguments that are really good for kind of climate computation or oceanographic computation or group by, so you can sort any of your dimensions into like certain time steps, or you could do like group by hemisphere, and so subset your data into just, if you're only interested in things going on in the northern hemisphere. Resample is sort of a version of group by, but specific to the time dimension. So I guess we'll do that a fair bit in our the next couple of cells, but If you have a data set that comes daily resolution and you're interested in monthly means, you can use that to really easily resample from daily to monthly. And without having a huge computational expense, which is nice. The rolling command takes a rolling mean. So if you're looking at 30-day rolling windows, it's easy to specify. I haven't used Corson, but it looks like that's for downsampling. So going from a higher res model to something that's not as quite as data consuming. And then the weighted command can be used like we'll get to that later as well, but if you're trying to take a spatial mean and your grid is on latitude and longitude degrees, then grid cells closer to the poles are going to be smaller, so you can use that to weight the values according to the actual area they're taking up. And I bet you could use that for other dimensions as well, but that's how I typically see that used. And then, yeah, I guess we were talking about how Xarray has awesome documentation. I think there's a few links to that here, besides the 404 page. But this is what we're working on, and then they have like a billion other example notebooks for more specific things. So yeah, if you want to dive into data structures, more like chunking or cloud-friendly formats, they are all over that. Sweet. So I guess let's check out some of these, how to use some of these commands. Here's our data set, same thing we started with. Group by, you just need to specify the dimension, and then it has a bunch of different inputs here. So here we're taking, eventually going to take seasonal means. We're just showing the groups. We have our 4 seasons. It's a little annoying initially because I think it just outputs them alphabetically. So we have December, January, February, and then it jumps to July. But it is easy to, here, yeah, let's move this up. So we can just write a list that will put them back in order. Oh, that's why that was down below. So here's our groups, and then we're just gonna add this command to take the mean. And so if we start with, yeah, I guess it's not even daily. This is a 6 hour, so there's four values every day. So we're just gonna separate all of those into groups for each month and then collapse them with that mean command. And now our time dimension has been replaced by season. That's gone from however many values, almost 3,000 to just 4. And here we can make things a little tidier by putting them in chronological order. And then, yeah, Felipe touched on this morning, but Xarray is also very compatible with matplotlib, so makes it super easy to make a quick plot. Here we're taking the data set we computed up here, and then all we need to do is specify the variable, use a plot command, and then we're just making it look a little nicer. Oh, okay. Yeah, so sometimes if you don't specify the variable you want to plot, you'll get a histogram. I feel like that's the default plot with Xarray. So with more simple data structures, you could probably get away with this, but when there's a little more going on. There we go. Yeah, so we took a seasonal mean using group by. You can also do super easy temporal means or resampling just with the resample command. So there's a bunch of different inputs. This is monthly. I think the E is for month end, so it's just on how the start and finish of the groups are being defined. To do yearly, daily, since we're already at some daily. Bunch of different options there. It's super easy to resample just with a quick line. Yeah, if we look at time dimension now, we just have January, February, so on. Back to plotting, I guess. So yeah, this is similar to the one we plotted up above. And then you can do all sorts of other different kinds of matplotlib plots just through calling contour line. Sure there's a few others there that you could track down from their website. And these are all just matplotlib arguments, but the Xarray is able to intake, so you can get something quickly with one line without having to write a bunch of extra code. Anyone curious about any of these commands? Yeah, it's nice when you just press Shift Enter. Yeah, and so then I guess this next part is like using actual data and not just what they have in the package. So if we wanted to write out across like one of the data arrays we just built, do this easy 2net CDF command. Should just show up in my working directory. Yeah, this one I maybe made. Oh yeah, there you go. I thought I renamed it. Yeah. And then this is kind of the basic Xarray read in command, open data sets. We're just reading in exactly what we just wrote back out. Should be the same. Yeah, Xarray also has a pretty sweet command. It's multi-file data set. If you have, I guess like a lot of netcdf files will come with one file per day if you're reading something in from AirDAP and wanted to collapse that into a single data array. You could use this command and then like use something like glob, which will go to a directory and build a list of every single file that's in one of those subfolders. Super helpful.
And should interpret globs if you put the string directly in there as well.
Okay, nice. Yeah, I done like that. Yeah, so I guess big picture, like this is what using a pandas data frame would look like for some of these multi-dimensional arrays. It's pretty messy pretty quick. Actually makes it easy to convert from that to a data array. So yeah, I mean, there's a lot going on there. Here, a lot more readable, a lot easier to work with. And then they also have a really big ecosystem of just compatible packages. So we've talked about Dask some, but that just helps load files in parallel. So if you have a really big data set, you can chunk it and then assign those tasks to different CPUs, so things will load in quicker. I haven't used many of these others, but I think Sparse is a package that deals with arrays that are just missing lots of data. So if you're working in an area that's heavily masked, that integrates with Xarray nicely. QPy gives you access to GPUs, and I have not used Pint before either, but apparently it works with Xarray. Yeah, a little more about Dask. So Xarray is really good about working with Dask. Here we're doing the same exact data loading, but then just going to load it with chunks. So for larger data sets, this can save a lot of time. Yeah. Here are all of our chunks. And that's just because we specified time steps of 10. I imagine for this data set that's pretty small. Yeah, 1/10 of a megabyte. I haven't used Dask a ton, but I think typically you're shooting for like between 10 and 100 megabytes per chunk. And then normally you're just choosing a dimension that you are gonna resample over because it's more efficient. Yeah, I'm hoping to learn more about that, and that's a little out of my expertise, but I think it's becoming more and more important with really big data sets that are out there. And then this is just using that chunked array. We can do the same exact things. Oh yeah, and then I guess another really beneficial thing about Xarray is that until you perform an operation or plot it or use the compute or load command mentioned here, it's not actually loading in the entire data set. So you can have an array that's representing a giant file and resample or subset, and you aren't actually going to need to load all of the data until you execute an operation that requires every single array value for what you are looking at, whether that's a certain spatial region or time subset. Yeah.
But that's only using that, is that right?
Yeah.
There depends on the engine. There's some it can be some lazy.
By default, Xarray doesn't do that. You have to use one of these chunks.
No, I think it does.
Yeah.
Yeah, like, and maybe it's different in the tutorial file, but like if you load just a normal old netcdf file, it is gonna have, yeah, a bunch of metadata, some values, and then it's not actually gonna load all the values. It has like, it's called like a task graph, so you can resample, and it's basically writing down the steps of what it will need to do, and then say you go to plot it and says, okay, I actually need to know the value at each of these grid cells, then it's gonna load in everything. Yeah.
So this feature that Tim's showing is really important when you start working with larger than memory data sets. And, you know, back when I started in grad school, like it was really hard to figure out how to work with these larger than memory data sets. And now with the Xarray integrated with Dask, it's so much easier. Like this, which Finn is showing, just, you do have to do, like, make sure the data are chunked. But if they've like put it up, a lot of data sets are already chunked because they know that you will not have enough memory to work with the data set. And then if it is chunked, Xarray will see, oh, hey, this is chunked. You want me to take a mean? Great, I know how to do that. I'm more advising it than Xarray here, but it'll do everything by chunk, and so it's not gonna blow up your memory, even though you're working with larger than memory data. One comment I'll say that I have gotcha that I run into is that, if I'm working with data in the cloud, so it's not on my computer, so it's up in the cloud, it's larger than memory. And I'll get sloppy and I won't look at what the chunking is. And then I will decide, oh, I should do a for loop and do 1 day at a time. And that's horrible if the data are chunked into like 100-day chunks. Because every time you say do day 1, it has to go get 100 days of data, and the slow part is getting the data.
Yeah.
So you kind of want to let DAS figure out the smart way to do things. Just look at the chunking, make sure it's chunked okay, and let it run.
I had a data set that the initial processing looked like it was gonna take 40 days. And once Dask and everything kind of were happy, got down to about 2 hours.
Yeah, I've gone from 2 months to 4 minutes. But in this case, it was chunked into, it was like little stream segments. And each little stream segment was super easy, fast to process. I didn't notice that it was chunked in 40,000 stream segments. And I was like, oh, I'm gonna do it for the, oh, it's so ridiculous, yeah.
So the key there is to avoid the use of for loops.
Yeah, yeah.
So how I'm told. So this is the equivalent of like you construct the indices as we saw above.
Mhm.
And then pass those through to some function that, like, what's the way to do that? To
Yeah.
avoid the.
The more that you can stay within the built-in methods and math operations. Those will apply to multiple, are able to be applied across multiple things at once. So if you do addition between your data frame or data set and or data array and a value, it can apply that same value to everything. If you have 2 data arrays, it'll try to apply it by the coordinates. But it can do those in parallel. They're independent steps from each other. If you're trying to do an operation, if you basically can make a function that takes one value and gives you another one in its place or some subset, you can do an apply or map or blockwise apply. There's a couple different variations. And it can do those at the same exact time.
Okay. So one of the gotcha places might be if you were doing calculation that required neighbors and go over some boundary. Is that where you?
Yep, that can be. There are operations for doing like a rolling window, different patterns there that can be more aware. Anytime that you end up near a chunk boundary, gets messy.
So better to find the method that probably already exists.
Yes.
Right, so.
Yes,
That's right,
someone else has bashed their head into that wall.
yeah. Multiple times. Okay,
Yeah, I really try and avoid like defining my own chunking and just rely on the built-in methods, which are normally pretty good.
I'll share one analogy I heard once about the chunking. It's kind of, they said something like, check if your data is like spaghetti or like lasagna. There's a spaghetti in the land, sometimes for, like time series, they chunk it like each time point, like for each location, let's say in space, you have like a time series, so it becomes a spaghetti. And lasagna is maybe like that, where you know your space is chunked. And depending on your application, you may need something in the middle, right? Like you may need these, or this is at one extreme, the other extreme. So you may kind of need to check that. Hopefully you don't have to change it yourself because you don't know the size, but if it's one of these extreme cases, you will have to change it, so pick your pasta type.
Can you define what the kind of chunking dimensions are outside of, like, do they have to be space time, or can they be completely arbitrary? I'm thinking like, I work a lot with species, like community data, and a lot of times it's like the site by species matrix. And then I have like multiples of those site by species matrices. So can I like basically say that my quote unquote spatial dimensions are sites and species, and then like is it possible to like go beyond the predefined scope of printed data that we kind of assume? Okay.
Yeah, whatever dimension you're making the grid out of can be used as a chunk. Chunk definition.
You just have to specify the dimension, it has to be dimension specified.
Right.
Right. Which can be tricky, but. Yeah, in that case, it might be tricky.
All right. Yeah, this is similar operations just with the chunk data set. And then actually performing the operation with compute. All of it is a sweet package. It's super compatible with Xarray. And it is just makes quick interactive visuals. So here we're taking our data array, making a quick plot, and then you can look at specific points to see the actual values of the arrays. And then we also added a little slider so that we can progress through the time steps. Yeah, and then I guess Felipe used CF Xarray a little this morning. I haven't used it a ton, but I think it's just good at using standard dimension names. So accessing data that you know refers to latitude in a certain way. And actually, I'm not sure that it is within. Cool. Okay. I tried it earlier and I didn't think it was within the environment of the hub, but yeah, looks like that works great. Yeah, and then a bunch of other potentially helpful packages. Yeah, I mentioned regridders earlier. XCMF is really good for that. So if you have two model array data sets that you're trying to compare and they're on different arrays, that's kind of the go-to for that. Definitely can be a little finicky within your environment and has a lot of dependency issues. Maybe that's easier in Pixie. Not sure, curious to try that. Intake Xarray will help build file paths that are compatible on Mac PC, use URLs, use the local directory, make your code super generalized. Rio Xarrays used for making like geotiffs from Xarray data arrays. Lots of helpful things out there. Yeah, I had another notebook that could just check some things out if you guys are interested in, but I don't want to kind of just go fly through it in 10 minutes, but
Maybe
what do y'all think?
they-
Yeah, totally. Yeah, and I guess everyone has it, so feel free to go run things on your own. But this is kind of more the typical analysis I will do with Xarray, and think it's pretty neat. So first cell here is just a data loading function. We've alluded to like cloud-friendly data formats. I feel like that typically is referring to Xarray, which is what we're accessing here. This is available publicly on Weatherbench too, which I think is just a Google served cloud platform. And so then instead of using open dataset, we're just using OpenXAR. defining our chunking. And then here, this is era 5 data. Instead of loading in the whole thing, we're just loading in one variable to avoid some of those size constraints. And I ran it earlier and needed to restart the hub and get one with a little more memory. So if anyone runs into a kernel quitting error, that might be the problem. When I ran this has taken like 40 seconds. So super reasonable for a large data set. Yeah, I guess the next step is just, yeah, nice.
I don't think you have to start it, redo that.
Okay.
Oh, you.
That's, you're in
something
the-
Bigger, never mind.
Yeah,
I think you just ended up in a different image.
I think I just went to one with a little more memory, which is what I was trying.
You chose more memory, but you had a different image selected. Yeah, you're.
Oh, it wasn't the default.
This image will be fine for Xarray.
Okay. We'll see, I guess. Yeah, so first few cells here, just accessing and loading the data. And then I guess this code's a little more complicated than just the default plotting code that we were looking at previously that comes with Xarray, and this is just adding some land features using Car2Py, great mapping, Python package, and then some matplotlib specifications. Oop. Sweet, so it looks like it did load that time. Yeah, so this is a data array instead of a data set, and that's just because we specified that we wanted just SST. Take my word for it. Looks pretty similar as our last data set did, just with some masked values. That's mostly just around the coasts. We make our plot, check it out. So we defined some bounds, added those land features, and then I just added this little rectangle because we were going to do some analysis later on how that Pacific Northwest coastal region compares to the entire SST data set. Yeah, so these are similar commands as we were using before, defining our slicing, taking a data subset, and then I mentioned this briefly, but taking that weighted spatial mean that just accounts for grid cells not all being the same size. And this is just how we actually compute that size difference. And then we can grouping by month, and just calculating our standard deviation so we can look at the monthly cycle. Here we're just filling in between the actual values and standard deviation on either side, defining our x-axis labels, yada yada. Next little section is computing temperature index. So we're just taking the spatial average over this region to kind of look at how SSTs has changed in that area over time. And then this is the temperature index anomaly. So we take that monthly climatology and subtract it from each monthly value to look at kind of a general warming trend along with intermonthly variance. And then kind of our last step here is we're taking this temperature index, subtracting the trend, so we aren't looking at any long-term effects, and then performing a little bit of just correlation analysis, which is built into Xarray using NumPy, and visualizing that. So we're just saying, okay, in months when sea surface temperatures in this region are warmer, what do the surrounding areas look like? So there's kind of an interesting dipole that forms between this region's warmer and north of Hawaii tends to be a little colder. Yeah, sorry, that was moving quick there, but thought those plots are worth checking out and kind of cool applications of it.
And
Go ahead, yeah.
You compared the SSPs, right, and this, so when you took the dictionary, how did you can you explain the part where you chunked comparing the
Yeah,
same platform?
yes, it's really just that line is doing the correlation analysis, and then the setup is like, so this is our anomaly. For like here we computed the anomaly for that smaller region that's in the rectangle. This is the anomaly for every grid cell in the whole entire data set. We're doing same linear fit as we did here, and then subtracting that just so it's detrended so that we aren't picking up long-term signals and we're just looking at month-to-month change. So it's really just this cell, and then we already have our, well, it's the anomaly index, and then I think down here we define the detrended. Yeah,